So, good afternoon, students. And today we will continue with the chapter motion. In our last class, students, we have done the average velocity calculation also. And today we will be doing some of the numericals, how and where we will be calculating the average speed and the average velocity. So we will begin it. But before beginning today's class, okay. Now, likewise, I will be sharing with you the white screen, and there I will be, we will solve the questions. So let us do today. Just a moment. Just a moment, students. Okay, fine. So let us start. The first question, you will be seeing in the screen also. The question will be visible to you, and we will solve it also. The first question, the odometer. Students, in the first class, I told you what is odometer also. The speed is calculated, or it is an device which indicate the speed. It is there in the car as well as the other moving objects. The odometer of a car reads 2000 kilometer at the start of a trip. So initially, during the start of a trip, the odometer of the car reads 200 kilometer, and 204 kilometer at the end of the trip. So you can see, students, initially it read 2000 kilometer at the start, and now it is showing at the end 2400 kilometer. Stop. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour. Just a moment. Yes, all the students have. Okay. Kilometer per hour and just a 1 minute. One minute, students. And and meter just a moment. And meter per second. Meter per second. Okay, so this is a question, students, that this is a question that how you will be, you have to calculate the average speed, and what you will do in the average speed. In the average speed, you have to, the odometer of the car reads 2000 kilometer at the start of a trip and 2400 kilometer at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometer and meter. Okay. Is it okay, students? The question is clear to all? Okay, fine. Now we will be doing the solution of this numerical. You all have written the numerical, I hope you all have written. Okay, now we will do the solution. Let me check. Okay. Okay. Now see, student, first of all, we have to decide that what is the distance covered. What is the distance covered? So in the solution, you will write down, this is the part for the solution. Distance, first we have to see distance covered by the car. Student, can you tell me what is the distance covered by the car? Distance covered by the car. What is the distance covered by the car? That will say S is equals to, can you tell me? Yes, very good. That is, yes, correct. 400 kilometer. That means 2400 minus 2000 is equals to 400 kilometer. 400 kilometer. Okay, 400 kilometer. Is it okay, students? Now you see what is the time lapsed. Time elapsed. What is the time elapsed, students, to cover this journey, or we can say to cover this trip? Yes, correct. Time elapsed is equals to 8 hours. 8 hours. Very good. So now the average speed of the car is Student, can you recall what will be the formula for the average speed? For the average speed, formula of the average speed, write in the chat box. Average speed, Jyoti, I have not said average velocity. I have said it is we are going to calculate the average speed of the car, not the average velocity. Yes. Correct. Correct, Harsh. Distance, yes. Total distance, yes, by the time taken. Very good. Correct. Yes. Correct. That is V average is equals to S by T is equals to 400 by 8 is equals to, just a moment, let me admit, is equals to, that counts to your 50 kilometer per hour. 50 kilometer per hour. Now, student, in the question, it was given to us that we have to calculate the average speed of the car in kilometer per hour. So in kilometer per hour, this is the thing. So first we have to calculate the total distance traveled or the total distance covered. So that accounts to our 2400 minus 2000, that is a 400 kilometer. Then what was the time taken to cover this distance? It was 8 hours. So the average speed will be the total distance covered, that is 400 by 8, that is 50 kilometer per hour. Now to convert this 50 kilometer per hour, first answer is this 50 kilometer per hour. And now we have to convert the 50 kilometer into meter and the whole speed, that is a 50 kilometer per hour into meter per second. So for that, what we have to do, we have to now 50 kilometer divided by hour, 50 kilometer divided by hour is equals to into 1000 meter by 1 kilometer into 1 hour divided by 3600 seconds. Did you got it, students? So 50 kilometer per hour, we are converting it into the meter per second. So that accounts to our, this calculation makes to 13.9 meter per second. Okay, so the average speed of the car, the average speed of the, 1 minute, the average speed of the car in kilometer per hour is 50 kilometer per hour. And when we are talking in terms of meter per second, then it is coming to 13.9 meter per second. Got it, students? So here we are converting that 1 kilometer is equals to how many meter? So 50 kilometer is equals to how many meter? There we have done. Then 1 hour is equals to 3600 seconds. So 3600 seconds counts to 1 hour. Then for 1 hour, we will be doing dividing the hour to convert it into second by 3600 seconds. We know that in 1 hour, there is a 3600 seconds. Now, is this numerical clear to all? Is the numerical, this numerical is clear to each and every students? Please give me the feedback through the chat box. Okay, fine. Okay, Priya Lakshmi, then Anupam, Saloni, Jia. Yes, Jyoti, I have not got your response, Jyoti, till. Ocha, question. I think my screen is visible to all, na? My screen is clearly visible to all students. My whiteboard is visible to all. Okay, yes. So yes, Jyoti. Okay. Okay, Jyoti, I repeat the question. It was that the odometer of the car before the start of the journey, it measured or it indicated 2000 kilometer, and at the end of the trip, it indicated 2400 kilometer. So the time lapse between the trip is 8 hours. So what is the average speed? So the average speed definitely distance covered by the time. So the distance covered is 400 kilometer and divided by the time 8 hours. So it becomes to 50 kilometer per hour. But to convert, that was the in kilometer per hour, and to convert it into meter per second, we are dividing them, or 50 kilometer to be converted into meter, we are multiplying it by 1000 meter, and the hour to be converted into second divided by 3600 seconds. That makes or counts to your 13.9 meter per second. Is it clear? Is it clear, Jyoti, now? Okay, fine, Jyoti. Okay. Okay, student, let us come to the second numerical. Let us come to the second numerical. Let us come to the second numerical. Now we will do the average speed and the average velocity calculation. Okay, so I'm writing the question again. I'm writing the question again. So this is question number 2. This is the second numerical. Usha swims in a 90-meter long pool, full stop. She covers 180 meter in 1 minute. In 1 minute, she covers 180 meter in 1 minute by swimming from one end excuse me, students, by swimming from one end one end to the other, and back along the, just a moment, and back along the same straight path, full stop. Find the average speed and average velocity of Usha. 1 minute. Find the average speed and average velocity of Usha. Students, so this is a question that Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to other and back along the same straight path. Find the average speed and the average velocity of Usha. Okay, so first, students, to solve this, first what we have to do? First, we have to take into account that what is the total distance covered by Usha. Okay, so for this, the total distance covered by Usha in 1 minute. First, we have to do that. So let us solve this one. Now, let us solve this solution. Total, first we will take into account total distance covered by Usha. Total distance covered by Usha in 1 minute is 180 meter. Okay, student, do you? I hope you all will agree with this. That is a total distance covered by Usha in 1 minute. That is swimming from one end to another is 180 meter. So now, student, can you tell me what will be the displacement of Usha in 1 minute? What will be the displacement of Usha in 1 minute? Very good. Very good. 0. Yes, correct. Very good. So we will say displacement by Usha. Displacement by Usha displacement by Usha in 1 minute is equals to 0 meter. Now, after this, students, after this, the average speed, again the same concept, average speed is equals to total distance traveled by total time taken. So here, what it will be? The total, okay, students, here I want that this step you should also calculate. Average speed, total distance traveled by total time taken. Okay, for this now I will unmute you, the participant. Now the next step, the calculation part, can anyone tell what will put the values over here? Let me interact with you all, otherwise only I am writing here. And meanwhile, now average speed, total distance by total time taken, what values will I put over here when we know that this is a total distance? And anyone? Yes, raise your hand so that I can unmute you. Raise your hand so that I can unmute you. Okay, through the chat box it is coming. Yes, 180 by 1 minute. Okay. Correct. So we will write this is equals to 180 divided by 1 minute. Okay, Harsh. Harsh raised his hand. Okay, Harsh. Okay, Harsh, yes, I have got the response through the chat box also. 180 by 1 minute is equals to 180 by 1 minute, 1 minute into 1 minute into 1 minute divided by 60 second is equals to, that accounts your 3 meter per second. It accounts to 3 meter per second. Okay, so here student, one part we have done, that is the average speed, which is the total distance traveled by the total time taken. That accounts to your 3 meter per second. One part is completed. Now the average velocity, student, this part I want that you should participate for this. Average velocity, what will be the average velocity and what will be the formula for the average velocity? For this, anyone, I would like to unmute you. Quickly raise your hand. What will be the formula for the average velocity? I'm writing here average velocity. You tell me the formula. Average. Okay, Jyoti raised her hand. Average velocity. Okay, let me write the term first. Average velocity is equals to, okay, first Jyoti, you can unmute yourself.
Yes, sir.
Jyoti, what will be the formula?
Sir, initial velocity plus final velocity by 2.
Initial velocity minus final velocity, that means that accounts to your displacement. Okay, displacement by total time. So we will be saying displacement, just a moment, displacement by total time taken. Okay, so student, what will be the value of displacement in this case? What will be the value of displacement over here? If you are talking about the displacement, what will be the value of the displacement? Okay, very good. 0. Very good. Correct. It is 0 is equals to 0 meter divided by time taken is 1 minute 60. So it is seconds. So that accounts to your answer 0. Just a moment. That accounts to your answer 0 meter per second. So student, this is the average velocity and the average speed of the two. The average speed is 3 meter per second and the average velocity counts to 0 meter per second. Is it clear to all? Is it clear to all the students? Okay. So today, this was the numerical which we have done, that how we will be calculating the average speed and how we will be calculating the average velocity. Okay. Now, let us come to the next portion of this lesson. Now, student, we will discuss the concept of rate of change of velocity. That is the concept of acceleration. Now, students, you might be knowing that acceleration, the rate of change of velocity of the body over time. So if you want, if you are talking about acceleration, then definitely that when a body is moving uniformly along a straight line, its velocity is constant. That is when it is moving in a straight line. Therefore, the change in velocity is zero, but over any interval of time. But when a body is in non-uniform motion, its velocity definitely changes. And that to express the rate of change of velocity, we need a physical quantity which is called acceleration. Okay. So students, we have defined acceleration as the rate of change of velocity of the body with time. And when we are about to do or derive the formula for the acceleration, then definitely the acceleration is the change in velocity. And change in velocity, definitely it means that final velocity minus initial velocity. So the formula for the acceleration is A is equals to B minus U by T, where U is the initial velocity, B is the final velocity, and A is the acceleration. So this is the equation for the acceleration. So student, this was about the acceleration. And definitely student, if you want to calculate the unit of the acceleration, then it is unit of acceleration, that means change in velocity meter per second by the time, unit time. So it comes to, the unit comes to meter per second square. Meter per second square. And obviously acceleration is a vector quantity because it has both magnitude as well as the direction. Okay. So student, this is all about today's class. So today we have done the numericals, some numericals on the average speed calculation and average velocity calculation. Then we have defined acceleration, its unit, its equation. So today the assignment with you for you all will be, you will practice the numerical which has been done today, and also you will prepare the terms which we have done today. Okay. So thank you students for today's class.